right. So my name is Ricardo Farinha. I work at Sweco. I'm in Sweco in Finland, and I'm currently the director of technology there. Today I'm going to talk a bit about what I believe can become the new superpowers in the construction industry. So to start with, we will talk a bit about the construction industry. So the construction industry in a whole is it spends $10 trillion every year globally. That represents about 11% of the global GDP, and it employs about 7% of the world's working population. So it's a huge, massive industry. So if I try to describe in a picture what the construction industry is, that picture is quite reasonable. So we have a planning phase, a construction phase, commissioning phase, and then operation, maintenance, and then we have a renovation or demolishing phase, and then it could restart over. So this is a simplified view of what the construction industry could be. As you can imagine, the construction industry has been around almost as long as we humans have been around. So this is a very complicated process that has been here and evolving all these thousands and thousands of years. But we at Sweco, we are basically focusing, even though we have a footprint in most of these areas, we are focusing mainly on the planning phase. So if you go to the Sweco website, you can read many times things like this, that Sweco plans and designs the sustainable communities and cities of the future. Sorry. So this basically is a subset of the construction industry. It's the AEC industry, architectural and engineering in construction. So the construction industry is huge, and it's also, there is some big problems in it. So for example, the construction industry is the second least digitized industries in the world. So it's just after agriculture. Agriculture is the worst, the first least digitized. Construction comes next. It's also in large projects, it's estimated that they take 20% longer to finish in average, and they are 80% over budget. And it's also estimated that about 57% of the operation in the construction industry, it's waste. So there's a lot of waste in our industry. If you look at the sustainability side, between 25 to 40% of the world's carbon emissions comes from the construction industry. So it's a very dirty industry. And about 40% of the world's energy is also spent on our industry in buildings, for example. And it's about also 1% of it's estimated that the construction industry spends about 1% of the revenue to R&D, so to find ways to improve. And also the productivity is growing about 1% per year, which is quite below the average. So there is these massive problems in the construction industry, and these are not new. These have been here for decades, and they are just becoming bigger and bigger all the time. If we jump to the AEC industry, so there is this common known problems also more specifically to this industry, even though they can also apply to the construction. There is a big lack of collaboration between the disciplines, between the different disciplines in AEC. There is the industry is quite fragmented, quite many silos. Even inside the same silo, it might be that they work in a different way, and the standardization is quite low as well. So you might have in the same silo 3 different teams, and they work in 3 different ways. There's not a standard way of handling things. It's also, there's so much things to learn nowadays. So there is so many new tools coming all the time, and things are just coming too quickly nowadays. And our people are always so busy, or the people in this industry are always too busy with the projects to be able to catch up with everything that's coming. And many times they don't even have access to data and knowledge. It's hard for them to get. And even if they do have access, it's hard for them to extract knowledge, extract information that could be useful for them, which leads that it's hard for them to see the big picture. It's hard for them to know how to improve because they don't know what's possible. So this means that we have this, it's hard for us to find information. It's hard for us to learn in the industry, which means that it's very hard to change. And that's, in my opinion, one of the reasons we have been so stagnant in the change and in the technology adoption in our industry. But we know that we are living in this digital age where technology is growing exponential. So we know that, like, if you think about it, the IBM is predicting that the amount of knowledge, the amount of data in the world is doubling every 13 months. So let's imagine the internet, for example. Imagine that the internet size is like this, and next 13 months it will double. The year after it doubles again. It's massive. It's amazing and insane how fast this new this knowledge is being created nowadays. So can we somehow use that as an asset? Can we somehow use that as the superpower that could help us, like, change these big issues that have been in our industry for decades now? And that's basically what we are trying to achieve in Project Wisdom. So, and what does that mean in practice? So we are now trying to find ways to capture and store domain knowledge. So how do our people design a school building? How can we capture the domain knowledge of that and effectively? And then we need to find ways to convert that data that we are capturing into actionable insights, which means that we need to understand what the data means, how it relates to each other, and then create, like, squeeze the wisdom out of that data. Because data by itself, without processing, might have value, but often doesn't have value. And then the third point is that we need to then, when we have the wisdom, it's still huge. So we need to find ways to target this wisdom to the right person at the right time. So if I'm a fire designer, for example, I might be designing some kind of in a project, in a timber project, I need to design some special case there. I could somehow be targeted knowledge or wisdom that was done before, so that it could help me, support me in my decision making when I'm doing the new project. And of course, the last but not least, it needs to be a dynamic system. It needs to be a system that improves over time, that it doesn't stay static, that the more you use it, the more data it connects to, the better it becomes, so that it's always adapting and changing depending on the user and depending on the use case. All right. And if you think about it, so think about the potential. So at Sweco, we have done 60,000 projects. And to do those 16,000 projects, we have spent 15,000 man-years of work. If you think about it, like, if Sweco would be a one-man company and we would have started in the Stone Age, we would need to work from Stone Age until today to do the work that our people at Sweco have done in just 1 year. So can we somehow capture this huge amount of knowledge? Can we somehow capture the way that the people do these projects so that we can then reuse it in the future? And that's basically the essence of Project Wisdom, to capture that information and then reuse it so that we can, over time, become better and better and help society and the different clients that we have to build the more sustainable communities of the future. And from now on in this presentation, I'm going to show you just a specific type of data. So Project Wisdom connects to different types of data. This is design data is just one of the types we connect to. But I want it to be a bit more specific from now on in the presentation. So think about design data. So every time a person inside Sweco, for example, a civil engineer or an architect, that they open the software, they are doing their job and building the buildings, roads, bridges. Every single action that happens inside the software is collected to these massive databases in the cloud. We have been doing this now for 14 months in this pilot phase, and we have collected information from over 20,000 building information models. So let's say 20,000 projects or 20,000 3D models. And these data miners, they have been active for a total of 820 years. So we are collecting 100 years of data every month currently. So this is how we capture the domain knowledge, how we capture the way that the design is done. Then this should be the easy part. This is the technology side. Then comes the hard part, which is squeezing the wisdom out of this data and then finding these kind of use cases which we can then target this wisdom to the right person at the right time so that then it does add value to the business. That's the hard part. And I'll show you 3 examples in this presentation about simple cases where we are doing that. So in the last 13 or 14 months, we have done, I think it was between 15 to 20 of these use cases so far. And of course, we are going to keep doing more and more in the future. But before we go to the use cases, I need to explain to you the different maturity levels of these use cases. And if we look at the graph now, so in the left side, in the y-axis, we have the value, and the x-axis, we have the difficulty and cost of the implementation. So now we are seeing when a person or a company or a system doesn't have access to data. So what happens in that situation is that you are using your instinct, you are using your intuition. You think it should be like this because you remember before that you have done it like this, or this person has told you that it could be done like that. So you don't base your decisions on data, you base your decisions on instinct and intuition. And there is a value there. That's why this is not in the zero level. There is a value in that. That's how people and humans have done for thousands and thousands of years. So there is a value there. But when we bring data to the table and knowledge and facts, we can start adding extra value to the process. And there's different levels. So the more to the right side you go, the more value you become. So it's like a step process. So you start in a descriptive layer where you can answer in questions like what has happened. That's basically, if you think about it, it's a window to the past. You can see what has happened. Then when you start going up to the diagnostic levels, you can answer things like, why did this happen in the past? When you go to predictive, it's what will happen in the future. So we start going from a window to the past to a window to the future. When we go to the last levels, in the prescriptive level, we can start answering things like, how can we make this happen? So we give a problem to the machine and the machine finds us a solution. That's the wisdom layer. And basically, the more right you go, the more up in this value chain you go, the more amount of data you require. After this, I'll give you 3 examples, and these 3 examples are in different steps of this stair. So the first example is a simple case. So we are in the data layer. It's the window to the past. What has happened? And basically what we are doing here is a system that is helping our Revit software coordinators to maintain the environment, the Revit environment. Revit is a software, a design software. So let's give you some numbers. So let's say for every 1,000 people that are doing design in Revit, there is like 10 people that are maintaining the environment for those 1,000 people. So they need to make sure that the Revit doesn't crash, that the models are good enough so that the 1,000 people don't need to wait all the time about something. They have the right tools available to them, and there's not big issues. So we have this system, these machines that are all the time checking the projects that are ongoing, and then they give notifications to the Revit software coordinators so that they can act upon certain things that might break the flow of our people, of our design. So this system like this has been helping us maintain and improve all the time the health of our projects or the health of our models. So this is a simple example of what we can do when we start using machines to analyze data to support our users. So together, the human plus machine together can add value to the process. We can bring superpowers to our Revit coordinators. Now they can act much faster than they could before. Second example is a bit more complicated. So we are in the information layer. We can answer questions like, why did it happen? So we can see we have a window to the past, but then we have this extra processing that allows us to understand why did it happen, and then we can act on it. And we change software. So we change from Revit to Tekla structures. And in here, in the software, we have a bit more than 1,200 people. And these people have been, in the last 14 months, inserting about 10,000, they've used about 10,000 unique tools in our projects. So these tools are, if I explain them, so they are parametric tools that allow you to do some connections between structural members, for example. So in that picture, you see an example of a tool that is used to detail a connection between a steel column and a steel beam. So the user selects the column, the beam, he selects a couple of parameters in the user interface, and then the machine, that tool, will automatically create the detailing between the two elements. So our people have inserted 27 million of these type of tools in the last 14 months, and we have collected 4.2 billion attributes that these people have inserted the tools with. And then we have built a system that analyzes all this data, and then it groups our users together. So, and the idea here is that when I go to a web page, for example, I log in there, and this shows me that there is, for example, if I'm the user connected here, it shows that there is, in this case, 4 people that are similar to me. They are working on similar projects. They are working the same type of design that I'm doing. They are using the same type of tools. 2 of them are from Finland. 1 of them is from Sweden. And 1 of them is from Norway. And then in the left side, it shows me the users and the tools, these parametric tools that they have used that I have never used. So, and it makes so much sense to show me these because there's 10,000 tools that our people have been using and probably plenty more out there that we have never even heard about. So we need to find ways to target information that is relevant to me. And this is a way to do it. So we can, from those 10,000 tools, 41 of those tools are relevant to me that I have never used before. So this is helping us to decrease the time that is required for this technology adoption, to start using this kind of power tools to help us in our projects to improve the quality of the design and so on and so on and so on. So it's speeding up the technology adoption, this example. So the last example is a bit more up in the ladder. So we are in the wisdom layer, in the final layers, where we can answer things like, how can we make this happen? So this is a design recommendation system. So it's a system that basically is trying to give recommendations for this type of elements. This is a precast wall element. This is pretty common in the Nordic region, at least here in Europe. So this is it's manufactured in a factory, then it's transported to construction site, and then the people are putting it together one by one, like Lego pieces. And why did we choose this? Because we have over 300 people that are designing this type of structures. So every single action they do when they design this have been collected. So, and we have also the tens of thousands of the final product, the already designed walls, finished walls that we have done before. So combining the final product, which is normally what companies have, plus the history, what has been taken, what are the steps taken to achieve the final product. Combining these 2 things, we can build systems that can then recommend us in the future when we try to design a new wall. So that's what we built. So a system that can predict, adjust, and learn. How does this work? So we have a basic design wall. The machine will make a prediction, what it could be. It will automatically understand how the reinforcement should adjust, because as you can see, the wall is longer than the original prediction. The machine learned how the reinforcement should be adjusted in this case, because it has learned that from the data, and it will understand how to adjust the reinforcement. And then the user will validate, because we are not building something to replace our people. We are building the superpowers that will support our people. So it gives a support for our people in the design process. So our people will adjust the result. In this case, for example, the wall is longer, so it's heavier. So you need to change the lifting and add an extra support plate in the middle. The machine is learning and seeing what the user has done, and it's adjusting. So next time it makes a different prediction when the same case comes. It has learned that there is this difference in the stud placement and in the strength of the lifting in this type of situation. So this is why we call that these are dynamic tools. They are not anymore static, that there's a coder or a programmer that codes 1,000 lines of code, and then it always works the same way. It's not like that anymore. So this type of new tools, dynamic tools, they connect to this huge amount of data, and they improve over time. So they understand and create rules, and then they adjust themselves. And this is basically why I believe that technology can help us bring superpowers to the AEC. So we can somehow use technology to basically give this access to knowledge and information that can help us solve some of those big issues that I talked in the beginning. So it can help us solve those big problems we have in the construction industry and in the AEC industry. Right, this was my presentation. Thank you.
Thank you, Ricardo. And now it's time for some questions and some answers. Listening your talk, it reminds me it was some years ago, it was quite popular Finnish company, Nokia. They were saying connecting people. So what you are describing, that if you connect people, then the results can be better, the money can be saved, and the buildings can be built faster. So this is very nice to see that connecting people is still relevant in Finland. Hopefully you will bring it to Estonia as well. So the first question to you is that to bring this knowledge to my company, what kind of educational background I would be looking for in that specialist?
We see actually nowadays the people that come from university, they are already quite technology driven. So they learn in school already a lot of these techniques or these automation techniques. So they are kind of more prone to accept these ideas. So I would see that in the future, when we are moving forward in time, people with those skills will be very important for our industry. So the ones that understand the domain knowledge, but they also understand the technology side and how it could connect to each other. That's I believe, one of the key factors that will allow us to solve some of these problems. Because, I mean, currently, I started in this industry 13 years ago, and back in that time, having a developer like myself in a company like this didn't exist. So they saw development as a cost, while nowadays they see development as an opportunity. So I think there's a lot of doors now opening with this new way of thinking. So trying to bring the IT and the technology side closer to the construction industry, I think, is the key forward.
So first you learn how to code, and then you will go and build some houses, and then these specialists are the best ones. How many people in Sweco is dealing with R&D in daily basis?
Well, I cannot give you an exact number because it's a decentralized organization and there's so many pockets of R&D inside Sweco that often are connected to each other and sometimes not. But here in Finland, the pockets that I'm working with, I think we have about, 7 to 8 full-time people. I mean, it's more than 7 or 8 people, but the amount of hours spent is like 7 or 8 people.
Okay, so not very much. You know how the things are happening in your company, but how are your competitors doing? So how is the market in Finland in general? So are they moving in the same direction, or you are like the pioneer?
I think this is a general movement. It's not a Sweco movement. So, like I said, I've been around in this industry in Finland since 2008. And it has been, I've worked in a competitor that is now a competitor for Sweco. And I also talk to a lot of other people around the industry. And I see that most of these companies have developments similar to the ones we have. And we actually work together in many of these projects that we put together different companies and try to push the industry as a whole. So there is this type of movements in Finland where we work together with competitors and with clients and with other type of people to try to push the industry forward. So it's not a Sweco thing, it's a general thing, at least in Finland.
Sweco also has a branch in Estonia. So will you bring it to Estonia as well, your great ideas?
Sweco Estonia is working together with Sweco Finland. We are in the same business area, so they are already using things like this.
Okay, very good. In your talk, in your presentation, you mentioned the superpower. But with a great power comes great responsibility. So what kind of responsibility do you feel with this superpower? So because if I think about other areas where artificial intelligence is being used, for example, playing Go. And the specialists in Go, they said, when they looked at how the computer plays it, they said that interesting, very good, but strange. So will we face at one point buildings that are good, but are a little bit strange?
Well, that's definitely a risk. But for example, one of the things that we have started this AI journey maybe in 2017. and we try to always have this kind of a explainable AI. So when we have let's say, some deep learning system that makes predictions, we try to understand in what features does the prediction is basing the predictions on. So what is the machine, why is the machine thinking that this should be the prediction? So we always try to be careful on those aspects. And in this field, in the construction industry field, this is extremely important because if you think that the AI builds a system that is not structurally sound, I mean, what the worst that can happen is that the building collapses and there's people inside. So it really needs to be like I need to understand what's happening. It's not so that, like in other fields, that you can make a prediction, but if it doesn't work, it's fine. It's not like that in certain cases in the construction industry. So that's one of the things that we have been focusing on. How can we say that this prediction is right? How can we prove that this AI module that is running in the cloud in a black box makes right decisions? So that's part of the journey that we have.
Yeah, this is interesting. It reminds me a little bit of flying with airplanes. So if people are asked that, do you trust computer and are you willing to step into the airplane that is run by a computer? And now we can ask the same question for building industry. Are we willing to step into the building that is designed by a computer, where artificial intelligence is making is taking a key part when planning it? And so yeah, with a great power comes great responsibility. Thank you. And hopefully the ideas that you mentioned will come reality at some day, hopefully sooner than later. So thank you for your presentation and the answers that you gave. So thank you.
Thank you.
Bye-bye.
Bye-bye.